Now here we have one of my little demo loudspeakers on a turntable, and I've added EQ to flatten the response. Now watch and listen as I add this 2-foot square baffle, making sure it's flush with the face of the loudspeaker. Wow, that effect is very pronounced. We clearly see a 6 dB increase in level at 250 to 350 Hertz. Remember our discussion of Q, that half-space loading redirects the energy that was radiating spherically into half the area, which is a Q of 2, and doubles the pressure at our reference measurement position. 2 divided by 1 is 2. The log of 2 is 0.30. 20 times 0.30 is 6. So we clearly see a 6 dB increase in pressure. Note that the size of the baffle is 2 feet, about the wavelength of 565 Hertz. But what we see here is useful addition all the way down to about 150 Hertz. 2 feet is a quarter wavelength of 150. So we now know that baffles provide a lot of benefit down to quarter wavelengths. Now logically, we would expect to see this 6 dB increase up around 500 Hertz, where the wavelengths are smaller than the size of the baffle. But we don't see that in our measurement, do we? Let's do a couple more measurements and see if we can figure it out. First, we'll measure the response of our cube at 90 degrees off axis. Here we see that our source exhibits directivity starting around 300 Hertz, and is progressively more directional from there on up. This explains why the peak of our baffle effect is at 300 Hertz, the highest frequency where our cube is omnidirectional. Let's do another measurement at 180 degrees and I'll add the baffle again. Well, it's quite clear that the baffle is very effective where wavelengths are smaller than the baffle, above 500 Hertz in this case, and has little effect at frequencies where the baffle is a quarter wavelength or smaller. Now the baffle does increase the levels of energy above its size in front. We didn't see it in front of the loudspeaker because the cube is directional above 300 Hertz, meaning less energy to redirect. Now this is why some of the loudspeaker systems I designed many years ago included a 2-foot wide plywood extension bolted to either side of a low frequency enclosure. The pair of 2-foot wide baffles added to a 1-foot wide low frequency enclosure increases the effective baffle width to about 5 feet. This helped to redirect the energy above 100 Hertz or so that would have been lost into the ceiling to radiate out towards the seats.